My name is Nathan Hadaway, and this is my Physics 2212 Lab 4 on bar magnets. What is this lab? Well, this is a lab where we took a bar magnet and we tested the magnetic field at different places around it, different distances around it, using an app on our phone. Um, After we did this, we simulated the same thing in GlowScript, and then saw how the real world and simulated data compared to each other, and saw if the physics equations that we used in um, in the GlowScript in the code saw if they were correct, which would happen if the um, data that we got from the code aligned with the data that we got from the real world. Again, going back to this, the system was our bar magnet that we were testing, and the surroundings was the Earth's magnetic field, and also our phone, um, which was calculating the field from the magnet. We also had to align the magnet and the tester with magnetic north, so that it was easy to get rid of the magnetic field produced by the Earth. Um, Next, what we have is what this lab is trying to prove is that the uh, magnetic field produced by this magnet, this is at the far far away from the magnet, so not right next to this magnet dipole, I guess is what you'd call it, is this equation mu naught times 3 mu times r hat minus mu um, divided by 4 pi times radius or distance cubed. Um, this lab also proves that the Earth has a magnetic field, and that is strong enough to necessitate us needing to get to align with the magnetic north of the Earth, so that we can take that out of our calculations. It also proves um, the direction that the direction a magnetic field is going from a magnet. We tested parallel to the magnet, so that's in line with the magnet. Perpendicular or to the side, the in the code we use the four cardinal directions away from the perpendicular to the direction of the magnet, and then we also did one at a 45-degree angle to the magnet to see how the magnetic field was at all these points. We also found the magnitudes at all these points of the magnetic field. So this is the simulated data that I got and some more useful code here. Again, if you want to look more at the glow script, it's earlier on in this lab. If you want to look at that, I don't know if it was on the second slide, I believe. I'll also probably put in the abstract. This is where we calculate this is where we create the arrows and calculate the magnetic field this is the first 2 points, the two orange arrows. The assumption that we made in the code was there's no magnetic field from the Earth. We're only considering the magnetic field from the bar magnet. And then we also used a simplified equation for magnetism because we used the far reach, the equation at a far distance away, which was shown in the slide before. Some frequently asked questions is, what if we hadn't we hadn't aligned our magnet and tester with magnetic north? This would have meant that the force of gravity not the force of gravity, the magnetic field from the Earth would have been included in our findings from the tester, and so it would have skewed our results, and we wouldn't have been able to trust that we were just measuring the magnet, because we would have been measuring the magnet and the magnetic field produced by the Earth. Now, what if we had two magnets next to each other, or kind of in line, I think is what the exact question was about. this would just double the magnitudes of all of our of the magnetic field, but it wouldn't change any of the directions because we are far away from the magnets. It would change the magnetic field close to the magnets, but because we're far away from them, basically all that it does is it just doubles it doubles the magnetic force. Thank you.